So our next speakers will introduce the ATT&CK LENS framework for dynamic visualization and exploration of the MITRE ATT&CK framework. These are Shankar Murali and Krishna, Chaitanya, Yeleswarapu. Shankar is an Associate Vice President with Standard Chartered Bank who analyzes and responds to cyber incidents. Krishna specializes in data protection strategies and compliance with global data privacy regulations. We'll hear from them about ATT&CK LENS.
Thank you, Sundar, for the warm introduction. Good morning, everyone. We are really glad to be here with you all today. My name is Shankar. I'm working in Standard Chartered Bank in PsyOps, as Sundar mentioned.
Yeah, I'm Krishna. So I work with Stancy as well. Before that, I was with Deloitte Consulting. So my specialization is with data protection.
Together, we will walk you through one of the research we did in predicting and visualizing cyber threat, inspired by the way how human brain works. Human brain perceive things and perceive and solve problems. Initially, we started with visualization. Later, we thought the same framework with an additions can be used for prediction as well. Let's do a small exercise now. Can we predict the next number? It's pretty easy, isn't it? Very easy. How? Actually, before starting all these things, we made it as abstract as possible so that it's easy to understand and comprehend. Can we predict the next number here? It's relatively difficult, but not impossible, isn't it? What if I say the first number is 2 pi and the second number is 3 pi? It's very easy than the first one to predict the next number. So the point here we are going to make is like the human brain works in a way that if you have the context, if you know the environment variables or prior informations, we will be able to predict with accuracy and less time. So if you really want to predict the next number without the prior information, it is not impossible, but we need a lot of computing, biological computing power along with time. So if you know the prior informations, we can reduce that and also increase accuracy. This is the concept of Bayesian, and we are introducing that into our solving problems in cyberspace. Let's go back to the first one. Most of us have predicted 5, right? This is because we are more logical in nature. So our logical brain was very active and we started to predict it as 5. What if we have been given more time and be a bit more creative? What will be the next number? We can think of 4, 5, 6, 7, or even some other imaginary number. Like we can think of Fibonacci series, prime numbers, or geometric patterns, even binary, exponential. It's endless. So the first one is logical in nature, which means most of us would have predicted 5, okay, which is deterministic. The next one, we are creative in nature. We are using the creative part of the brain to infer the next number. We are combining all these 3 different functions of the brain, the creative side, logical side, along with Bayesian model into a model pipeline. So we use traditional AI, generative AI, and Bayesian thinking, which comes as an ML model. So this is a pictorial representation of the model. So you can think of the traditional model where it is logical in nature and deterministic. We try to use Markov chain along with hidden Markov chain. On the right side, you can see a transformer. It's a BERT-like model where all the LLMs, we are using LLMs. So any of you have tried? So we tried today morning that I have a context and both of us are inputting the same request to ChatGPT, okay, along with the same context. But the output is totally different for both of us, mainly because the probabilistic nature of it, because it's so creative. And it also leads us to some kind of hallucination. So we are using generative AI for that, and which is again, the output varies depending upon the environment. Both of this is inputted into Bayesian model where we are using probabilistic refinement. So we can think of like in terms of data, in traditional AI on the left side, the data which we are using is similar to what is used in MITRE's TIE. Okay, MITRE's contribution in developing TIE is really good. And I think they have used around 6K real incident data, which is a stream of TTPs in JSON format. So this we are training that model with the same data, and the generative AI transformer or BERT-based model is also being trained with the same data. So when the output of this deterministic model will be really static in nature, and probabilistic model will change over time. Every time when we initiate it, we will get different output. Both of these are put into Bayesian. So in Bayesian model, the training is done by the environment, whatever the business environment is. So we take logs from SIM. We can train it with the security settings, threat intelligence, attack exposures, all those things. And the final output will be a refined output. So the crux here is like the way in which the human brain thinks, which is Bayesian in nature, that is being integrated into the pipeline. All three micro models will give us some kind of output. So we can think of one of the example. Let's take an example of an attacker attacking an environment. So he will have two different options. In the initial phase, either we can go with valid accounts or spear phishing. What should I choose to attack this environment? In the case of on the left side where we are using the traditional AI, that model will generate, which is again trained using the historic attack. The output most probably will be, the output most probably will be phishing. Okay, on the right side, the output will be totally different. It can be valid accounts or some others. So when the phishing and valid accounts together come into Bayesian model, the Bayesian model understands the environment. Maybe MFA is disabled in that environment, or maybe the credentials are exposed in dark web, or there is the remote services like RDPs or VPNs are being exposed to public. So all these contextual information will be there in the Bayesian. Together, it will generate an outcome. So I just created a small graph out of it. So you can think of this. So there is a 70% chance that the attacker will choose. Here it is, we are using two different, another example, where either should I use PowerShell or VB script in the execution phase. So after phishing, I can either choose VB script or PowerShell. So here in this environment, there is a 70% chance that we can use PowerShell. And from PowerShell, it's moved into obfuscation. And after obfuscation, it moved into the different techniques. So all these together contribute into a weightage. We are giving some weightage and the output is there. From this, I'll hand over to Krishna, who will give a visualization framework, because whatever you're seeing is very miniature in nature. So he will walk you through the other side of the research.
Yeah, thanks, Shankar. So I think you got a good correlation between the left brain, right brain, and all those stuff. So let's move on to the visualizing part, because it's no good without visualizing just prediction. Okay, whatever you see, it looks like a galaxy of stars, and it's a higher universe, right? But this is basically some part of the MITRE data that we have that we generated as a knowledge graph. So this knowledge graph, looking at it, it would be good, but it's not useful. Just using the wholesome or a high level MITRE data. So the prediction output you can easily convert into a visualization. However, what we have done, we just took one step further. when a analyst or someone from the cyber, they can just log on to the UI and then they can give the customized field inputs. So what is the source type? And because in the universe you have seen earlier, so what we have done is we have put a nucleus that can be a threat actor or a malware or the procedure, and then the nodes would be, or the edges would be the other two parameters, and this can be customized. So the first part what we have done is you have the option to choose it from the drop downs, and then select and generate the visualization, the custom visualization. And then we went one step further and done like a generic chat. Here we have leveraged the LLM and the natural language processing aspect of the AI part. So where you can just give a prompt stating that, okay, I want to compare the current attack that happened in, let's say, Iran with the previous attack that's there in South Korea and some other malware. What is the correlation between all those? Give me a visualization. So that will give an output similar to this. So I think this is much simpler when compared to the universe you have seen earlier, right? So this can be this can be a easiest way to look at the data. So just let me quickly explain the architecture that goes into this. So first UI is there, which is similar to the one you are seeing below. So that is integrated with the LLM, but LLM is grounded by the RAG. Here we should thank MITRE, where we can use more realistic data and eliminate the hallucination part, and that will generate a code, MITRE code, unique code, which will be fed into our knowledge graph universe that we generated, and that will give an output filtered knowledge graph, the output knowledge graph that you are seeing, but not in the visualized part. So what we have done is we have leveraged the PyWays. So through Network X, we generate this to the PyWays. Sorry, we sent it to the PyWays and generate the graph you are seeing there. So quick example is, so the Iranian nuclear power plant attack that happened, one of the user or the analyst wants to understand what is the relation between that and the South Korean Olympic attack that happened with the WannaCry malware. So there you can see that it's not visible. You can see it, enlarge and see it. So the Stuxnet, which is used in Iranian versus Olympic destroyer and WannaCry, it's correlated among themselves. So that's the visualization part that you can see. What are the common actors that are there, and what is the common techniques that have been used, and what can be the expected outcome. So that would be helpful from the visualization part. And you can customize this as well going further. And finally, to summarize, like the predictive part that was shared by my friend, where the human brain is correlated with the model that's being created for the prediction and then the visualization. And what we're going to do next is like,
the system. Hello. Yeah. The system will not be good enough if human is not in the loop. So we are thinking of placing human in different stages of prediction and visualization, because visualization more of static in nature, where there is no probability involved. But wherever the probability involved, the human element should be there. So we are putting human in the loop. That's going to be something that we are doing. The next is like uncertainty and certainty. So basically, if you want to be more certain, it's very hard in this, especially in cyberspace. So we are trying to understand the uncertainty as much as possible so that we can be certain, a kind of Socrates philosophy. And the final one is the explainable AI. In the sense, whatever AI is doing, sometimes it gives us an output which humans are unable to comprehend. So their explainable AI part is, there are a lot of research that are happening. So we are trying to incorporate that as well. We are collaborating with few of the researchers in explainable AI space. So that also will be included. And these all things are in pilot phase, like a prototype kind of thing. And in terms of accuracy, F1 score, and all the measurements of the model, it's still in very nascent stage. So when we started with all the MITRE data around 6K real data, the accuracy initially was in all the epoch, we were getting some 56 or something around that. The benefit of this in relation to the TIE, it will actually complement the TIE and other tools. In MITRE Caldera also, we have a lot of ML models that are being used. So that also we are trying to leverage, which will help us to enhance the overall work.